We're now going to talk about adding two mixed numbers, and there are two different ways of going about this. Let's first talk about method one, and that's when you add the whole parts and then add the fraction parts. Okay, so let's go through this. So what's really important is that you recognize that when we're given 2 and 1/3, that's saying we've got 2 plus 1/3. And then I'm plussing onto that, so I'm plussing onto that. I'll come over here. I've got over here 4 and 5/6. So this is 4 plus 5/6. So even though there isn't a plus here, there's an invisible plus here. When you've got 2 and 1/3, it's saying you got 2 plus 1/3. And when you've got 4 and 5/6, it's saying you got 4 plus 5/6. So now the pretty obvious thing that you can do here is add the whole parts first. So I've got 2 and I've got 4. Well, 2 plus 4 is 6. And now I just need to worry about, and I'll use my colors again. Now I just need to worry about going, all right, I've got 1/3. And I've also got 5/6. So now I just need to add those two parts together. Now to do this, I'm going to have to do some creating equivalent fractions because I can't add these at the moment because the denominators aren't the same. So I want to times this by 2. And by timesing that by 2, what I'm going to end up with, and I'll keep it all the same colors now, is 6, 2 on 6 plus 5 on 6. And now the denominators are the same. I can add them together. I'm going to end up with 6. 2 plus 5 is 7. 2, 6 on 7. Whoops. 2, 7 on 6 rather, sorry. 2, 6, 7 on 6. Now, you might think, is there a nicer way to represent that? Because at the moment, I've got a whole number and a mixed number, a whole number and an improper fraction, and we don't like that. So what could we do? Well, what we could say is that this is the same thing as 6 plus 7 on 6. And then I could say, all right, 7 on 6 is the same as, well, how many times does 6 go into 7? It goes in one time with 1 left over. So that means what I've really left with here is 7, 1 on 6. And that's your final answer. So it's really important that you just become really comfortable with manipulating fractions in these ways. So that's the first way of going about it. Now, the other way of approaching the same question, so this is the same question here, is first convert the improper fractions. So convert to improper fractions. So take these and convert them to improper fractions, and then just add the fractions. So remember what you're going to do here is you're going to times and then plus. And then over here, you're going to times and then plus. So 2 3s are 6 plus 1 is 7. So this will be 7 on 3. And then on this side, you're going to go 4 6s are 24 plus 5 is 29 on 6. Then we need to get our denominators the same. So what I would do is I would, and I've used red, I'll have to use orange now. I'm going to times this by 2 and this by 2. And what that's going to leave me with is 14 on 6 plus 29 on 6. Now I need to say, well, what is 14 plus 29? 14 plus 29, what is that going to be? That's going to be 43 on 6. So I'll write that down. To get my pen. That's going to be 43 on 6. And, we could actually double check this, because if we were to take this, because remember, this and this, they're the same thing, aren't they? And 7, 1 on 6. Well, what's 7 times 6? 7 times 6 is 42, plus 1 is 43. It'll be 43 on 6. Or you could think of it another way. How many times does 6 go into 43? Well, if you grab your calculator, and I think I might have my calculator here, if I come over here, and I go, all right, what is 43 divided by 6? It should go in 7 times. It goes in 7 times. So it goes in 7 whole times. That's because 42 divided by 6 is 7. And then I've got 1 left over. So it's going to be 7 with 1 left over, 7, 1 on 6. So hopefully you can see how that works and how we're going about this. So these are the same thing. So it just depends on how you like going about it. Either way is fine. And yeah, hopefully you enjoyed this. I'll see you in the next part.